So a very good afternoon and welcome to all of you to this AICTE sponsored Distinguished Chair Professor Lecture Series by Professor Dr. Ashok Mishra sir, and who is the NASI Distinguished Professor from IISc Bangalore and former Director of IIT Bombay. And the topic of his lecture today is fostering creativity and innovation in science and technology. Sir, once again, we welcome you on behalf of Narula Institute of Technology, and we request you to please kindly take forward the session. Thank you, sir.
Yeah. All right. Thank you so much. Where is this Narula Institute of Technology located? If we can.
Yes, sir. It is in Kolkata, and it is located in the just outskirts, a bit outskirts of Kolkata, in North 24 Parganas. Yes, ma'am.
Sir, if you give permission, I can let you about the institute in 2-3 lines, sir.
That would be very nice.
Yes,
that would be very nice.
Yes, sir. Thank you, sir. Actually, first I have mentioned that we are very much fortunate to get you in this session, and the session will continue for further few days. We are really very much fortunate, like you, distinguished professor, to give the lecture. Sir, actually, this Narula Institute of Technology, this institute has started in 2001, and this group is approved by AICTE and affiliated to Maulana Abul Kalam Azad University of Technology, West Bengal, as well as the Narula Institute of Technology under the group JIS group, which is a big group in the eastern region. And at this moment, in this academic year, the Narula Institute of Technology offering 10 BTech programs and 4 diploma programs, 5 MTech programs and MCA programs. These programs are offering by this institute, and around 3,000 students are there. And the institute is ranked in the NIRF ranking band. However, the band is not very satisfactory. But since 2017, when NIRF has been started, since then to till date, for the consecutive 5 years, NIT, Narula Institute of Technology, has secured a position in the NIRF ranking. Initially, it was 150 within 150, 150 to 200, 100 to 150 rank. Then now it is within the 200 to 250 rank. The institute has been accredited by NAC in 2014 in grade B, and this year 2021, actually academic session 21-22, we have submitted the SSR to NAC, IIQA, then SSR to NAC for renewal of NAC accreditations, and already SSR has been approved. We are waiting for the peer team visit. Already we got the visit date, 4th and 5th March, our peer team visit of NAC. The institute has been accredited, has been announced as an autonomous academic institute by UGC as well as affiliating university and state government in 2015 for 6 years, and 2021 February up to 2021 session. And in the month of February 2021, we have submitted the application for renewal. We have received the letter from UGC for visit, but till date we have not finalized. We have not received the final date of visit by the expert members. That is, and about the programs. Among the programs, all the eligible programs are NBA accredited or applied for renewal. At this moment, 4 BTech programs, these are accredited by NBA, BTech in Electrical Engineering, BTech in Electronics and Communication Engineering, BTech in IT Information Technology, and BTech in Civil Engineering. However, we have applied for renewal of accreditation of these 4 programs as well as for the BTech CSC programs also, and also we have applied for renewal of accreditations for the MTech programs for NBA accreditations. This is about us, and the institute has also received the prestigious QS ranking, and in 2021-22 session, this Narula Institute of Technology has been considered as a mentor institute under the Institute Innovation Council of MHRD and AICTE. Under this mentorment scheme, our institute has become the mentor of 5 mentee institutes, and this mentee institute are within the West Bengal. Among these 5 mentee institutes, 4 mentee institutes are the private engineering college, and one is the National Institute of Technology, Durgapur. This is little bit about the National Institute of Technology, sir. And once again, I am very much thankful to you, sir.
Thank you so much for giving me such a detail, because you know it's easy to read, but when you tell like this, it gives a much better picture of what the Institute of Technology is. All right, clearly, as you go forward, the challenges are there, and you have to take your institute forward and up and up. I will discuss a little bit about what I think one should do in terms of research, innovation, creativity, and all that. And let us see if there are any questions, we can take them today, or if you wanted interaction with the faculty, just with the faculty, we can do that some other day. So if you'll allow me to share my screen.
Yes, sir. Yes, sir.
Yes, sir.
Shomo, please.
Rupa, please coordinate.
Yes,
sir. Yes, sir. You can, sir.
Okay. Okay, so my talk, as I had given earlier, is research, creativity, innovation, and beyond. Most institutes like yours, as I have seen in my experience, are very good in undergraduate education. But although you mentioned a lot about MTech students and some PhD, but I'm sure you have a difficulty in getting quality MTech students. This is not your problem, it's a problem throughout India. But what can we do in terms of research and innovation and so on? This is what I will focus on. So I start with a very simple slide, that what is the importance of higher education? Higher education is the backbone of a country's future. And all countries that have advanced technologies and economically robust have very good, robust higher education institutions. The budget just came out yesterday. I would like to see a huge amount of money spent on higher education in the country, which is not the case. So examples that you will see that USA, England, Germany, France, Japan, many other countries, they put a lot of money and a lot of effort in higher education, and they are count. I just took a random sampling for all over the world. Teaching standards have to be as good as anywhere else in the world. Students must be able to adjust to jobs in different parts of the globe. Keeping in view that the students in one country may be employed in another country, cross-cultural aspects had to be part of the curriculum also. Now, Pandit Jawaharlal Nehru, our first Prime Minister, had the vision to make India self-sufficient in its technological needs. And this will only happen by institutions like yours. We have to produce manpower to carry out research, development, design. That's what he said. And indulge in industry and technological growth. We should inculcate a scientific temper, which will attract the best talent. We have to create institutions that will provide the required ambience for education and research. So higher technical education is really the backbone for providing quality manpower for the industry and for our technological growth. Sound?
Now please mute yourselves. Please mute yourselves, all of you. Sorry, sir.
So no problem. In today's world, we have to have a sound base in sciences, and including biological sciences these days. Excellent teachers are essential. They have to have synergy with the industry, develop cross-cultural disciplines within sciences and technology, and then across sciences and other subjects like economics, business administration, finance, law, and entrepreneurship. So develop a research strategy with high priority. Have top-class research facilities. If they are not there in India, there are enough facilities at other institutions that you and your faculty and students can use. Enhance interaction with the industry. Commercial research for industrial development. We have to create intellectual property, which is based on the develop new ideas, inventions, and innovations. Research and innovation leads to entrepreneurship. Higher education institutions with a strong focus will have a greater future. Science is the base for the development of all technological growth. Advancing nations have to be strong in science. There is no shortcut there. Good technology follows good science. Hence, a level of education and research in science and technology at higher technical institutions should be there. I'll just give another example. We produce approximately 50 lakh students at the 12th class level in science. This is greater again than the population of several countries, like New Zealand is only 5 million, which is 50 lakhs. Austria and many other small countries like this. Yet, when we go and see at several research labs in the country, there is a shortage of good researchers. Why is this? The system should provide ample opportunity for this to happen. So, the generation of new knowledge requires people. We have to invest in people. Science is people. Everything that comes into science and technology is from people's minds. So it's the people who are going to contribute to this. So outstanding researchers will produce more inventions and innovations. Productivity is based on this. Research and creativity is basically at the heart of new economy. So we have to invest in people with a focus on India's long-term economic strategy. So India's science and competitive strength, we have a huge opportunity to make a difference. We should do it on a mission mode. So this is how the pyramid that we see. We have fundamental science leading to applied science, engineering, technology, that's where you are. But you have to have some science base also. And then business, marketing, wealth creation, and GDP. So this is broken up into science, research for the knowledge's sake. The technology is where you are, the application of knowledge to economic growth, and then directed research that in several countries, especially in India, let's say we have to focus on water, which some countries may not have the need for it. So we have to have some areas in which we have directed research and then translate that into applications. The synergy in science and technology is really influenced by directed basic research. Then we go to entrepreneurship. Universities to have an ambience where innovations flourish. Our logical follow-up, as I've said earlier, also is incubators, innovation centers, and research parks. Venture capitalists should flock around the campuses in search of projects of commercial value. Development of new ideas worthy of commercialization will require high level of research focus. Such universities will provide opportunities for growth of new enterprises. So this is just a table here. Institutes of higher technology, higher education, ambience of creativity, generation of new knowledge, new ideas, intellectual properties for public good or wealth creation. And you can have it like this. That is R&D, technology demonstration, prototype, manufacturers, sales, marketing, and of course, technology incubation or wealth creation. So what the leaders need to do for enhancement of research? Leaders have to have a flair and appreciation for research. Increase stretch on research. Have a dean of research who will manage the research and innovation activities. Identify some areas of focus which are their strengths. Increase the number of PhD students. I do realize that this is a challenge in India a lot, even though so many people, 5 billion, are finishing science at the 12th level. By the time they reach to the PhD level, we don't get enough PhD students. But we can bid for research projects, make an ambience that will attract high-end research scholars. bring in research at the master's and bachelor's level. One of the best students that you will get in all colleges, including yours, would be at the undergraduate level. So you can think of developing undergraduate research opportunities. So if you teach 2 or 3 courses less, but challenge the students towards a project, research project, in which he or she can get involved in, then that will contribute to the research culture in the institute. Also, sometimes I also mentioned the thing we did at IIT Bombay was to have a dual degree program, BTech and MTech together. This way you can produce BTech plus MTech in a 5-year program, and they will be a little bit more suited for the industry and research and development. So all technologies begin with inventions. Inventions drives technologies, and you have seen that in communications, there was a telegraph, telephone, cellular, internet, and of course it keeps on going. Information technology started with computing, then semiconductors, software, AI, and so on. Biology, vaccines, biomedical devices, diagnostics. So we have to develop intellectual property that will give enormous socioeconomic benefit. Who is an inventor? Who is a researcher? Either a researcher, faculty member, or just a student, or just an employee, entrepreneur, independent consultant. Anybody who can think out of the box and come up with new ideas is a potential inventor. And now I make a little distinction between inventions and innovations. Invention is foray in the unknown, whereas innovation is putting together the known for novel effects. So, for example, your talk of chips and all these electronics and on which so many transistors, millions of transistors are put in a very small area and so on. But all that began when silicon was invented in terms on which you can write, you can etch the circuits and the information on it. So that was a real invention. And then, of course, innovations are how many more chips you can put in a particular area and increase the power of computing in smaller and smaller devices. Most of us innovate. Only a few invent. We only innovate on the move unless action follows, process is not complete. So I'm in the area of polymers. I give this idea of cross-linked rubber. Goodyear invented the vulcanization of rubbery polymers to make them into cross-linked elastomers. And rubber gained worldwide importance with this invention of air-filled tires, which were developed by John Dunlop. You all are familiar with Dunlop tires and Goodyear tires. These are the two inventors who invented it. They enabled the making of tires and tubes. Of course, now we have tubeless tires and so on for the automotive sector. If they had not done that, cars would still be running on wooden wheels. But it's the rubber which was invented and the tire and the tube. Because of that, you can make the tire and the tube. That the automobile industry started to have tires that we see today. Innovations have improved the tires over the years, long-lasting, which you feel the bumps less, radial tires, this, that, and so many other things that have come up. And of course, with the cross-linking, many other uses for elastomers have come up, like the conveyor belts that you see in airports and similar items in the consumer world. Then I give the example of the water jet cutting machine. This can cut steel, brass, aluminum, and so on. Now, it is just water jet. What is the basic principle is that if you can put water in such a thin jet, very fine jet, the force with which the water comes is enough to cut, but the force is very high. So that is the basic science behind it. It's physics, basically. Physics is if you put liquid through an orifice, finer the orifice, the more force with which it will come. And then the technology that follows, how to make that orifice, how to make that water pressure so high that it can come out and cut metal, and so on. So there's an invention, then there's technology, and then there's growth. So the golden age of invention is now. But that's wrong. It was 10 years back and it will remain 10 years later. Camera, for example, when I was growing up in my younger days, we had a camera with a film and we used to take photographs, get the film developed and this and that. And Kodak was a major company to do it. And then came the digital camera. All those films, Kodak company is all gone. Okay. I have several cameras sitting with me, which are starting from the beginning. Movies, the way we see movies has changed a huge amount. Radio, instead of having a radio, basically your mobile phone has a radio in it. Light bulb has gone from incandescent light bulb to CFL and LED and whatnot. Surgery has improved in many, many ways. Phone is an example where we had a phone which was, dial the numbers and so on. Then push button phones came and that went. And now the phones that you have handheld devices are absolutely a marvelous equipment that you carry. And vaccines were being developed, but suddenly COVID comes and then we find that we don't know enough. So new vaccines have to be developed. So all these, in any of these things, new things are always happening. Television. There was a time when I used to work on liquid crystals, and I said one day this television screen will be made of liquid crystals, and you will be able to hang that on a wall. And everybody said, no, this picture tube television, which is huge and all that. How can you say all that? Today, youngsters will not even know what the old kind of television, which had a cathode ray tube type system, looks like and what it did. So people are forgetting what used to be, and so many other things. So camera, I gave an example. Some of you, the older people, will remember there used to be box camera. A photographer will come and put black cloth on his head and take a photograph. Then came the box camera, then all kinds of cameras, single lens reflex camera, and now the cell phone that you have in your hand. The cell phone that you have in your hand basically is a camera, okay? And it also has 2, 3, 4 cameras, front camera, back camera, and whatnot. And everybody is now a photographer. Everybody they used to be photographer, now everybody with a mobile phone says, it's photographer. Earth these inventions, and that is, I did the beginning with this innovations and research and creativity and all that business. But then now I'm trying to bring in some areas. The digital divide, the COVID basically accentuated the digital divide. The digital divide between the rural and urban people, those who had and those who didn't have, especially in terms of education. So this has to be addressed too. Now they're talking about with the budget has done something so that you will get some concession on mobile phones. We have to break the digital divide. The biggest sufferers of education were the rural children because they could not have, or they did not have it, and they could not afford a smartphone. Food and resource management always remains a problem. How much food do we lose because of improper storage? How many things we can preserve by preservation methods? Water management, I don't even have to tell you how bad our water management in India today is. Every year we talk of this, that, all kinds of demonstrations are there for water distribution and sharing and whatnot. We have to do something about water management. Energy generation and distribution, it's a huge challenge. First of all, coal was there, and I don't know how many of you know that when you burn coal, only 36 odd %, let us say 40%, goes into energy. 60% is just lost. If we can harness that coal burning or any other fossil fuel burning, to get a higher efficiency and reduce the distribution losses. Healthcare, I already talked about. Healthcare was really tested hugely in times of the last 2 years of COVID pandemic. Waste management, I'm a polymer person, so people say, oh, there are so many million tons of plastics in the sea, so ban plastics. But how did it get there? It is people like you and me, the educated, civilized people who have indiscriminately thrown away plastics into streams, which goes into rivers, which end up into the sea, which causes this problem. So waste management is a huge thing. Ecological balance, we talk about climate change and so on and so forth. This is going on and on and on. How much can we change the climate? Nobody is reducing energy consumption. Okay, some small percentage energy is produced by solar energy and so on, but there's still a long way to go. And of course, terrorism, counter-terrorism, and now with the drones and all that, it's even one worse. The drones are attacking, and then we have to have drones which will kill the drones which will come to attack. So all this will go on. So we can divide this up into in many, many ways. Automotive technology. So you can take one theme, let's say automotive technology, and then you can look at the battery or air separators or lighting or sensors. And today, some of you must have been reading in the newspapers that car production, car requirement has become less. And they say it's not because people don't want cars, but the integrated circuit shortage is there. So therefore, cars are not so much available. But their air pollution, air purification, should we go for materials which will make it lighter? Is it safer if it's lighter? How do you make it more safe, the car, with airbags? So many things are all the time being invented in the automotive sector. And similarly, any sector, if you take the aerospace sector or a food sector, things like that, which I've talked about, there's an improvement or new technology which comes every year. I was looking at a car which now has a 360 view. So you're sitting in the car, you can look around the car when it's trying to park and all that. It was not there a couple of years ago. And then you can divide this up into the areas of invention. So it could be either sensors, bio-waste, food, construction, medical, whatever turns you on, whatever area you feel passionate about. You mean the teachers and the students. You can think of new items that can be developed, whether it's materials or whether it's packaging. New kinds of packaging are coming all the time. And of course, nanotechnology is a big buzzword, so that is coming. Social networking, I only use WhatsApp. I don't go to any other thing like Facebook and all that, but many people go to that. And new kinds of social networking platforms are being created. This is another, just to give you an idea, in IIT Kanpur, there's a very nice group on flexible electronics. One of the best groups in the world, not India, in the world, on flexible electronics. So all kinds of things are going on. Printable electronics, they're trying to build organic solar cells, printable inks, memories, sensors which will be on food products, which will automatically show that this is now too old to eat, and things like that. And of course, OLED lighting. This is a startup by a student of ours from IIT Bombay. He has made these robots. He calls them micro, and they're about 10 inches big. And they are programmed and connected to internet. And these days, when many families have just one child, there's no companion at home. This basically becomes a companion at home. You can talk to Miko. I saw my granddaughters talking to Miko. Said, come on, Miko, play some music. Let's dance. And then Miko puts some music on and starts actually moving around like a dance. And my granddaughter was happy to dance with Miko. Ask a question. What is the capital of this thing, like say Russia or wherever. So general knowledge can be gained by this. Miko also asks questions. So this is an interactive robot with artificial intelligence. Nanotechnology, and I won't go to all of them, but in every area, material science, engineering, carbon nanotubes, energy, catalysts, information technology, optics, biotechnology, we're talking of nano particles and so on. Many, many areas of nanotechnology are there. There's energy storage, agriculture, water treatment, disease diagnostics, drug delivery, food processing, air pollution, many, many areas. Some students from IIT Roorkee, whom I know well, and I'm sort of mentoring them a bit, they have come up with aluminum air battery. And what this does is that inside this car, instead of having an electrical battery, they'll have this what they call liquid battery, in which there's an aluminum sheet and water, and it produces electrons going back and forth to produce electricity so that they can run this car. When all the aluminum gets used up, you stop somewhere, remove all the, because now aluminum has become aluminum oxide, you remove this liquid from which aluminum can be extracted, put a new rod of aluminum, one or 1.5 bottles of distillery, and you are ready to go again for the next 5, 6, 800 kilometers. That's what they're claiming, 1,000. So you don't need a battery junction where you have to plug in your car and recharge your battery. So these people have also developed some other unique things. They have developed a sponge based on graphene, which will take up spilled oil spills and so on. They're very simple things people are working on. Then there are people at IIT Kanpur who has developed hollow fiber membranes. And I'm giving these examples that these are not, all of them are not rocket science, things that you teach in classes. And if some people are innovative, they can start thinking of this such, and we have one of these at home, needs no electricity, can be installed anywhere, works on gravity pressure, and gives you clean water based on this hollow fiber membrane that they have developed. We talk of solar cells. I have a solar cell on top of my roof. The other day I saw it was so dirty. I don't think it's very efficient enough. If it rains every day, it's fine, but in India, it doesn't rain every day. So these people are, not for home, but for larger thing, they've developed a solar panel cleaner. This is very unique that it's called pool.com. You can go to the website and see. What they do is they collect flowers from, this is a Kanpur-based, IIT Kanpur-based startup. And what they do is, this is all the polystyrene foam, which is after packaging thrown away and it doesn't degrade by itself and occupies a lot of space. They collect flowers from temples and process them to make this kind of thing, which could be used for packaging. And once it is done, flowers degrade it's biodegradable, so therefore obviously these will be biodegradable. They had given me little idols of Ganesh, use them for the Ganesh festival, and when you immerse them, they're basically made of flowers, so they dissolve away very easily. So people are thinking even of simple things. Another company that I know in America is based on coffee flour. So what they do is when you have a coffee, the seed is there in the between, and outside there is a soft cherry. If you dry that cherry, the weight of dried powder will be equal to the weight of the seed. So it's 1:1 ratio again. And this normally thrown away for mulching and to make manure and so on. But if you dry it and take it out, you can make coffee flour. And this coffee flour, you can mix it with wheat or corn or some other materials. It is gluten-free and it's got some nutrients. So things which we were throwing away for years, like the flowers, and now the coffee. Flowers is in pool, and this is like in atta flour. People have begun to use this, and they made these cookies and cakes and all that business, which is much healthier than the pure flour materials. So the development of universities have to be of global standard. This is just to wind up. Knowledge requires people, and science and technology doesn't come from heaven, it comes from the minds of people. So it requires people. It's the people, not just money, who are at the heart of the knowledge economy. Outstanding faculty, which is people at a university, will attract outstanding students and research funds. Knowledge economy therefore requires wide range of people with specialized knowledge and experience. Education and research are thus at the heart of the new economy, and institutions should focus on that. Investing in people should be central place in the country's long-term education and economic policy. And I stress the fact education, which is sometimes ignored in the country. And what people said, Alan McDermott, a Nobel laureate, he said science is people, because how does the word science come about? People thought of explaining things, explaining phenomena which they observed, and therefore that term became science. And the most beautiful thing that we can experience in the mysteries is it is the true source of all true art and science. Imagination is more important than knowledge, and that's where creativity and innovations flourish. And our own C.V. Raman said, ask the right questions, and nature will open the doors to her secrets. If you want to understand the future, we have to create it. So he's basically a management guru, Peter Drucker, but just putting together some thoughts that creativity and invention is absolutely central. You don't have to have huge research facilities, but just thinking out of the box, thinking of new things, even in your syllabus, even in your curriculum, is important. So explore the infinite possibilities. There's huge impact that we can make through the opportunities that research and innovation offer us. So I kept it a little bit simple with some examples. I'm happy to take questions.
Thank you, sir, for your illuminating lecture, and you have covered almost all the aspects of science, technology, etc. And now I would like to request all the participants to please ask sir questions. Sir will enrich us with his knowledge.
Sir, thank you for your very informative lecture. I am Sumit Nandi, faculty of this college. I don't ask any question, but I would like to know something from you, because as we know that energy is a very important sector at this moment in our country. And we are discussing different renewable energy sources.
Yes.
So like in some area, on which area we should concentrate on more, like whether it is solar or hydro or biodiesel or geothermal, etc. If you please enlighten us regarding this issue.
Yeah. Good, very good question. And the answer would be whichever area that you feel most comfortable in, because all of these areas will emerge. So supposing at your college you have 5-6 people interested in solar, then you should all work together in solar. I must also mention that, at a college like yours, single person saying that I am the expert and work on it will not easily work, because some of these things are large in nature, and cross fertilization of ideas and efforts is required. So whichever area you have 4-5 people, a sizable group which they would like to stress upon, whether it is solar or hydrogen. One would be more chemical oriented, the other is more material oriented, or biogas even. bioenergy, that is a big thing. There's a company in Pune called Praj Industries, which is all bio in terms of the energy production and so on. So whichever if there's a nice mini group that you can form to take it forward. That is the area you should stress on, rather than just saying, it's easy to say I want to work on that, but if you don't have expertise, what can you do? You can't just suddenly build expertise. So to build on your expertise, and then automatically new avenues will open up.
Sir, actually, I have very little work on biodiesel. And I also published some papers on biodiesel, but still I did not find very large area where our country is taking some opportunities, some issues regarding the production of biodiesel large scale.
Yeah.
I have some information regarding in south, nearly I think in Chennai, railway actually started very good infrastructure regarding the production of biodiesel from vegetable sources.
Right.
But still, I think it is not up to the mark in a country like us.
Yeah, so what happens in any area like biodiesel, it has to be of a sizable size because the requirement of energy is huge. If you are just making a dent and it will make only 1%, 2% effect, it's very, very small. So you have to have scale and then you have to have economics. That what you make with biodiesel will also compete. Unfortunately, economics comes into the picture. Is it cheaper than coal, the energy that you make? Coal, as I mentioned, was slightly inefficient, but it's the main source of energy throughout India, and at least 70% is still coal. If you can increase that efficiency. So one has to work on that, and there are companies. I remember in Bombay, my younger colleagues were working on biodiesel, and they had a tie-up with Cummins. Cummins were making generators and motors and all that. So they were trying to rate the generator they were trying to run on. So, and as I mentioned, the industry involvement is imperative. So if you can get the right industry to come and help you with this, you can take it forward. So everything is, I gave a lot of things in one short presentation.
Okay, sir. Thank you.
Okay. Sure. I hope I answered your question.
Okay.
Yes, sir.
Anyone?
Yes.
Hello, sir.
Yes.
Yeah, I'm Dr. Shourav Shah from Computer Science Engineering Department of NiT.
Yes.
So I have a query. And anyway, thanks for sharing your valuable views on this particular topic. So my query may sound trivial, but given the current scenario, what we have been saying that we are finding it very difficult to motivate nowadays students to do serious research work. Many of the students are mainly interested in getting jobs. That in last year, in final year, and most of the students are devoting maximum amount of time in preparing for campus placement and for job. So, what is your suggestion? How to motivate them in best possible way to get into innovation and how to inculcate that research. I hope I'm able to.
Good. You're basically talking about the undergraduate students, right?
I'm talking about UG students, sir. So how to motivate them in best possible way to kind of research.
So if you give them projects at the undergraduate level, undergraduate research opportunities. So what happens with the teachers is they say they are not willing to cut any courses down. So if you talk to your affiliating universities and say, if you cut 2 or 3 courses down, let the students do a project in which they'll come up with something new and give them credit for it. Some incentive. Then they're more likely to get involved. So the other problem is that when you're saying they're looking for jobs, unfortunately, most of them are looking for just IT job. Even if you do civil engineering, they look for an IT job. They look chemical engineering, you look for an IT job.
You're right, sir.
That has to change in the country. I mean, I'm just telling you, it's a bad scene, but L&T, which is in the backyard of IIT Bombay, stopped coming to IIT Bombay for hiring because they said, your students don't stay, they go away to other jobs. So this is, of course, it's a problem of the nation. They have to change it somehow so that people who are trained for, when you spend a lot of time training people for electrical, mechanical, and civil and chemical, they should contribute to those energies. So all I'm saying is, if you can motivate them to, in your course, do some projects and paper writing and give an incentive to that, then that will help.
Thank you. So we are talking about, sir, giving incentive in terms of credits, right?
Yeah. In terms of credits, some incentive. I'm not saying money, incentive of credits.
Okay.
And if you also, I mentioned that if you do a 5-year integrated BTech MTech program, but you have to see if your affiliations will allow that, but you can bid for that. Then automatically you get 4 full clear years. Only after the 5th year they look for a job. So you gain 1 year.
Okay, sir. Thanks for your suggestions. Thank you.
Okay, we look forward for more questions. Any more questions?
Yes, I have a question.
Yes, sir.
Sir, my name is Omlan Chakraborty.
Yes.
My question is, there is a lot of hype going on about AI and ML, artificial intelligence and machine learning. Now, every student, they get somewhat mesmerized whenever they hear about AI or ML, that they want to work on AI and ML without understanding what it is. And, this is affecting the fundamental knowledge and the innovative ideas in daily life. And instead of focusing on the daily life problems, the students' focus, that get changed into the technologies.
Yeah.
So, how to address this problem? This is the biggest problem I find today.
Yeah, true. I know what to do. But AI and ML is touching lots of other areas. They're touching manufacturing, they're touching agriculture, they're touching drug delivery, drug discovery, and so on. So if you can get this AI to be of use in some areas, like a directed AI, not just AI for its sake, then that can be of use to develop some new ideas.
Sir, what I am saying is that this
I know what you're saying. Let me go one step backward.
Yes.
Let me go one step backward. When the student comes, he or she, first choice of department is what? Computer science, right? Why? Computer science is not going to put food on the table, okay, or car on the road. You need mechanical, electrical, and everything. See, this is a hype which unfortunately in the country has gone around, that if you get a high rank, you want to take computer science. So this must change. So AI level within computer science has now reached that stage. AI hi kar raha hai aapko. What to do?
So actually,
social problem
before learning AI and ML, one must learn
You have to learn the basics.
Yeah,
right, absolutely.
Then only they can apply AI and ML. So it is.
But you have a control on the course. You have a control on the syllabus. You can be strict and say, I will teach it only this way. Then
there will be no takers. There is a danger also. There will be no takers. Nobody will get it.
Doesn't matter. You have to try it.
Thank you, sir.
Sir, I have a question, sir. As I am also of a polymer background, so I feel that in today's world, still the most vulnerable problem which we are facing is the non-biodegradability of polymers. although some research has been carried out, but still I think we have not been able to commercialize to that extent.
Yeah.
So what can be done in future so that we may come up with very readily available biodegradable polymers like biodegradable PVC, which are very regularly used, biodegradable polyethylenes or polystyrene, etc., etc. So
Yeah.
what can we do?
So, yeah, some development is going on in terms of building biodegradable materials for packaging of the single-use packaging. So single-use plastics. But it's a challenge. It becomes more expensive, and sometimes it will not last so long. Sometimes, supposing you are packaging something in a biodegradable bottle in the bathroom, let's say shampoo, and it's biodegradable, and if it degrades, what will happen to what is its packaging? So you need stability on one hand, biodegradability on the other hand. But there are problems you have to solve. These are, as I said, if there is reuse, recollect, and get some energy out of it, people are working on. They call it upcycling now, not recycling, upcycling of polymers to solve this problem. But I'll just pose another problem. You're talking about carry bags and all that. Many of you probably don't realize when you are driving a car and you go say, okay, give me some new tires. What happens to the old tires? At one time, they were just burning it to get some energy out. But it's got sulfur and so on, so it cannot be burnt. So somewhere they are piling up, the used tires. One of the biggest dumps in Canada, which caught a fire, bigger than a forest fire, was the car tire dump. So we are consumers, a consumer society. So we consume, and I mentioned that waste management. So handling of waste management is a very, very important aspect. Biodegradability is only one aspect of that waste management. If you can collect all the polymers. Now, the other day, I looked at it from a different perspective. There was a little video which is circulating, which there's a lady, not very educated, who is sorting out the plastics from the waste. When you now the waste is into wet waste and dry waste, and the video was actually for a different reason. It was that if you throw your mask in that waste, these ladies are susceptible to, supposing the mask was worn by somebody who had infection, then they are exposed to it. But what I got from that thing is that they know how to segregate, without knowing the knowledge of polymers. They can segregate by the feel, polyethylene, polypropylene, PVC, and the like. So this sort of expertise does exist. But it is up to us to make sure that it is disposed of in the manner which is requested, that all the plastics go in one bin so that somebody can separate them out. What we do is all the kitchen waste, we like to put it in one plastic bag, seal it up and throw it. And then the cow is eating it, and then you say the plastic has gone into the stomach of the cow. But who is responsible? The person who threw the kitchen waste in a plastic bag for the cow to eat. So it's all this is a little bit of a social problem also. But people aren't working on biodegradable waste. Reliance has come up with some new biodegradable packaging, and it seems to be working quite well. But it has to be on scale. It has to be also commercially viable.
Yes, sir. Commercially, it should rise more. The non-biodegradable nature of the plastics, that I think we should implement more in society. So any more questions?
See, those of you who are getting material, some order from, let's say, Amazon, you would have experienced that small article is coming, but the paper packaging is huge.
Huge.
Cardboard packaging is huge. And then they say, oh, this is recycled, so it's all right. But nobody pays attention to how many trees you have to kill to make that much paper.
So environmental issue also sets in.
So sometimes it's one-sided, but they don't look at the other side. The paper doesn't come without its own problem. Paper mills, they produce toxic waste which goes into the stream, and so on. So it's a lobby here, lobby there. Waste management, I mentioned, is a huge challenge. We can talk about one lecture on just waste management.
Yes, sir, definitely. Sir, so what do you suggest? Do we rely more on polymers and plastics, or should we go for papers and all other natural products? Which is more important for us?
There is no one answer. So for some things, paper will have to be there. For some things, plastics can be there. But proper disposal and proper recycling, reuse, and all that has to come in. Biodegradable will be only one part of it. It will never be.
Yeah, that is okay, sir. Yeah. But as we go more for papers and all, that means a lot of felling down of trees, cutting of trees, and all those also will set. We have to keep a balance. We have to keep a balance of everything. Yes.
Yeah. Somebody was talking about saying, "Oh, you're an India energy, this thing, you're using so much." And this person had a house in the Northeast in Massachusetts, and a small condominium in Florida. You will be shocked to know when people in Florida come to the north in the summer, they leave their condominiums with air conditioning running for 6 months continuously. And they talk about others consuming more energy. Because why they are running it continuously? Because they say when we come back after 6 months, it'll smell, it'll be mildewy, it'll be this, it'll be that, all kinds of things.
So isn't it dangerous, sir? Isn't it dangerous to leave just 6 months with the ACs on and all?
I don't know about that. But this is a fact.
Okay, sir.
So people talk, but they don't. They have to. Everybody has to contribute. But packaging, polymers are a good packaging material. One of the lightest for carrying capacity. Let's say 5 kilos of atta or potatoes. Which other material for this 6 grams of plastics will carry? No, very few. So it has an advantage, but that is also the disadvantage because it's so light and so small that you'll have to collect for example, you'll have to collect too many to get some money out of it. If you throw it and collect and recycle properly, that is the answer.
Yes.
But let's say you get milk at home in polyethylene bags. Would one like to go back to glass? The answer is I don't think I would. I would remain with the plastic bag. But so 1 kilo, if you get one, it'll take you about 3 months or 2.5 months to collect 1 kg for which you will get take care of. Okay, yes, we can talk about that.
Sir, your voice is breaking, I suppose.
Any other questions?
Sir, are we audible, sir? Yeah. Now it's okay, sir. Yeah.
Yeah, of course. Yeah, I can hear you. Okay, thank you for giving me the opportunity to share some thoughts.
Thank you, sir. We are absolutely delighted to have you. And now I would like to request our principal madam to kindly felicitate you with a virtual memento because we are unable to meet you personally, physically. So
don't worry about it.
Yes. Thank you, sir. Thank you, sir, for delivering such wonderful as well as very informative sessions for all of us. Thank you so much. Kindly accept the virtual memento, sir, as a token of respect from Untitled Technology, sir.
Thank you so much.
Thank you, sir. Thank you so much.
Thank you so much, sir. And we look forward to meet you again on 8th at 3 p.m.
Okay.
I will send you the link, sir, through the mail.
Okay, we can do that. I think let it be a more interactive, active session next time.
Okay,
that you all come up with some thoughts and then or can send some questions ahead of time rather than just one-sided
Okay,
blah
sir.
blah.
Okay, sir. We will look
But
into
you
that.
decide. You decide.
Sir, first of all, we would like to hear from you. First of all, we would like to hear from you something, and then we will try to interact.
But I'll make it shorter next time. So.
Okay, okay.
Okay.
Okay, thank you, sir.
Okay, bye.
Have a good day.
Thank you so much.
Thank you so much.
Thank you so much.